Hey 7th graders, today's assignment is the Genotypes and Phenotypes worksheet. So to kind of start us off today, the first thing you guys will need to do is add some notes, and it's going to take me a little bit, but I'm going to go through these notes. These are probably some of the most important notes that we go through all, really it's probably the most intensive. I go through our notes all year. But these two concepts are really important for you guys to understand basically the rest of this genetics unit and even moving forward into some of our other units. So your learning targets for today. I can identify the possible genotype or genotypes when given the phenotype for a trait. So obviously you guys are going to learn what a genotype and a phenotype is. And I can identify the phenotype when given a genotype for the trait. Okay, so first thing you guys need to do is open up your OneNote, and you're going to add the phenotype notes to the phenotypes page and obviously the genotypes note to the genotypes page. So let's take a look right here on phenotypes and genotypes. And you guys can go ahead, take a second, pause this video, go get these notes in, and then we're going to go over them together. So I'll go ahead and give you guys a second to pause and do that. Okay, so let's go through these notes. So you guys should have added them both to your notebook. If you guys kind of take a look, here's my phenotypes notes under my phenotypes page with my traits and reproduction section. And same thing, here's my genotype notes. They're going to take a second to load for me, I'm sure. Okay, and we're going to go through these notes, but also there's a little example page that I'm going to do for you guys. So we're going to go through that as well. But let's go ahead and start with our phenotypes. I'm going to go ahead and just make this a little bit bigger for you guys. Okay, all right, so phenotype. First of all, we already know this vocab word of trait. Trait is a specific characteristic. Okay, so if we're looking at eye color, that's a trait. Hair color, that's a trait. Whether you can roll your tongue or not, that's a trait. Okay, and then we know that there's a lot of different variations for those traits. So if we're looking at the trait of whether or not you can roll your tongue, we can see two different variations. You can either roll it or you can't. Okay, for the trait of eye color, there's a lot of different variations. We can see blue eyes, brown eyes, hazel eyes, green eyes. Okay, and then everything in between, because we're not always able to group eye color into just a specific thing because it's so unique. Okay, so there can be several variations or phenotypes. So another kind of word for variations would be phenotypes. I personally like to describe phenotype, notice how it starts with PH, as the physical appearance for a trait. Okay, it's generally what we can observe, and we can't observe all phenotypes. For instance, when we talked about PTC tasting, that's not something I can look at a person and be like, oh, they're a PTC taster. Okay, it's a physical appearance that we can observe for the most part, but we could still test that one and see what their phenotype is. Okay, but for the most part, stuff we could observe. So again, I like to remember phenotype because it starts with PH, and so does the physical appearance. So notice how I kind of drew a little box around that there. Okay, it's all the different variations or physical appearances for a trait. With this, we can see dominant or recessive. And in real life, I mean, what we learn in science, we kind of learn a little bit, especially 7th grade science. What we learn is a little bit more black and white. But in real life, there's a lot more gray areas. So when we talk about eye color, like blue versus brown, okay, we generally say that brown is the dominant phenotype and blue is a recessive. So if one parent passes down the trait for brown eyes and the other parent passes down the trait for blue eyes, we're going to see the brown-eyed trait in the individual. Okay, so if those two are competing, again, we'll see the dominant show up and the recessive will not show up, but that doesn't mean they can't be a carrier for the recessive. Okay, so all of the variations or the physical traits appearances for a trait is the phenotype, and they can be dominant or recessive. So if we're looking at our trait of thumb shape, whether you guys have a hitchhiker's thumb or straight, those are our two different variations. Okay, we know out of that the dominant phenotype is hitchhiker's thumb. So more often than not, you guys will be able to see people when they put their thumb up, they can kind of bend it back and it curves a little bit. Okay, so that's dominant. Recessive is a straight thumb. Like no matter how hard they try, this is as far as they can get their thumb to bend. Okay, so that's your recessive trait. So again, if one parent passes down the dominant and one parent passes down the recessive, we're going to see the dominant trait in the kid. That kid's going to be able to pop their thumb back. Okay, the dominant, again, is the phenotype that shows up over others, and the recessive is expressed only if both parents pass it down. So people with straight thumbs, both the parents had to pass down that gene to their kid in order for it to be shown because there's nothing they're competing with there. Okay, so let's look at this little table here. Again, I'm going to blow that up. I'm going to do a couple examples for you guys, and then I'll ask that you guys pause the video and do a couple examples for yourself. Okay, and then we'll come back to this video and take a look at some of these. The kids in class did this on paper today. So what we see in this is the trait for tongue rolling is a dominant trait. So if you can roll your tongue, that's a dominant trait. Okay, that means at least one of your parents passed you down that gene. Okay, both could have, but all we need with the dominant trait is one parent to pass it down. Offspring who inherit this trait from their parents can roll their tongues. Children who do not inherit this trait from either parent cannot roll their tongue. So that means both parents pass down the non-roller trait. All right, so we have some examples. Here's what mom passes down. Here's what dad passes down in this column. And then the offspring's phenotypes. Remember, with phenotype, we're looking at physical parents. What would that be? So the trait for tongue rolling, mom passes it down. So mom passes down the tongue rolling trait. Dad passes down the non-roller trait. Because the dominant trait is this tongue rolling trait, the kid is also going to be a roller. So that kid should be able to roll their tongue. Okay, mom passes down the non-roller trait, and what we notice is that the offspring is also a non-roller. Since this is the recessive trait, okay, that means that both parents had to pass it down. So mom obviously passed down the non-roller trait. That means dad also had to pass down the non-roller trait. Okay, here we've got the dad passing down the non-roller trait. We know the kid can roll its tongue. That means somewhere in there they got the trait to roll their tongue, as it is the dominant trait. So that means mom must have passed it down. I'm going to do one more example for you guys, and then I'm going to let you guys finish the rest and see what you can figure out. Okay, mom passes down the recessive trait. So this is kind of a little vocab practice for you guys. And dad passes down the dominant trait. Okay, so if we go back up and kind of look at our tree, the trait for look at our key, the trait for tongue rolling is dominant. So right here it says dominant trait, so that means they pass down the trait for being able to roll their tongue. And that means the recessive one would have been a non. Okay, so we've got one roller gene being passed down, one non-roller gene being passed down. That means our kid is going to be a tongue roller. Okay, so go ahead, take a second, pause this video. I want you guys to finish the rest of this table. There's 3 little questions for you guys, and see if you guys can finish it out. And then when you come back, we'll check your answers. All right, so you guys should have finished this table. I'm going to go ahead and go through the last answer with you, and you guys can kind of check to see if you're correct or not. Okay, so if we have 2 parents passing down the recessive trait, both of which are non-rollers, okay, then we will see the child also be a non-roller. They're also going to have the recessive trait, okay? For this one, we don't know what dad passed down, okay, but what we do know is that mom passes down the dominant trait. Remember that anytime that dominant trait is passed down by at least one of the parents, that's what we're going to see in the individual child. So this child is going to be a roller just because mom passed down the dominant trait. It doesn't matter what dad passes down, whether he passes down the dominant roller trait or the recessive non-roller trait. That kid's going to be a roller because mom passed down the dominant trait. Okay, and then finally we have an offspring that's a non-roller. The only way we can get that recessive trait of a non-roller is if both parents pass it down. So that means both of our parents here had to be a non-roller. Okay, all right, second thing you guys should have added to your notes is this little notes on genotypes. So we're going to go ahead and go through those. Same kind of process. We got our notes that we're going to go over. And then we also have a little bit of practice just like we saw. Okay. These are some of my favorite things that I do all year. I think you guys are going to really enjoy them. Okay. So I'm going to go ahead and go through those with you. And just the same. Sorry about the little telephone interruption. Okay, so genotype is a combination of alleles or genes. So what we see with the phenotype is a physical appearance. We get to see what the individual actually looks like once their body's been kind of put together with all the proteins, using the instructions for those proteins. But what we can't see is what the actual DNA looks like. So that's kind of what the genotype is. If you guys look at the word genotype, first 3 letters kind of remind you of gene. Okay, and we find genes in our DNA. They're those little sections of our DNA that code for a certain protein which influences a trait. Okay, so a genotype is the combination of genes or alleles. Okay, alleles is a really important word that we're going to use a lot. Basically, when we talk about our genes that we're passing it down, we're going to look at alleles. And alleles are going to be little letters that we use to represent, okay, whether the parent is passing down the gene for a dominant trait or a recessive trait. So 2 letters showing what mom and dad pass down. Again, we talk about mom passes down this gene, dad passes down that gene. Those are both alleles. And when they combine in the offspring, that's going to be the offspring's genotype. okay? So allele is a different gene variation for each trait. So for instance, if we're talking about that same concept of tongue rolling or non-tongue rolling, we might use a capital R because it's our dominant trait to show that that's dominant, it's a tongue roller gene, versus our recessive trait, we would use a lowercase r, and that's a non-roller. And so capitalization is going to be really important in these, you guys, okay? You get one allele from mom. So mom can either pass down a big R or a little r, depending on what mom has, okay? And one allele from dad, again, either a big R or a little r for each gene. You guys can really use any letters. It doesn't matter. These aren't letters that we actually find on our DNA. They're just representations. They're something that we use to indicate kind of what we know about the genes of the parents. Some more vocab for you guys. So earlier in the year, we learned that homo means the same, okay? So that's really important when you guys remember this word homozygous, okay? When we're talking about a homozygous genotype, we're talking about a genotype or a combination of letters where they're the same as far as capitalization goes. So dominant versus recessive. So if I say homozygous dominant, okay, we're looking at two of the same alleles for the genotype that are both dominant, okay? If I say homozygous recessive, we're looking at two recessive alleles. So two examples of those would be for a homozygous dominant, big R, big R. Okay, that means that mom passed down a big R, dad passed down the dominant big R, and that individual offspring would be big R, little r for their genotype. Okay, homozygous recessive, okay, would mean that both parents passed down their recessive allele, and therefore the offspring has this genotype little r, little r. So if we're looking at tongue rolling versus non-tongue rolling, this homozygous dominant would be a tongue roller for sure. This one would be the only one that's a non-roller. So the only option for the genotype of the offspring that is not a roller would be little r, okay? Heterozygous, hetero means a mix. So we see two different alleles. So we see a dominant and a recessive. So one dominant allele plus one recessive allele. So the genotype for that would be big R, little r. It means one parent passed down the dominant, one parent passed down the recessive. If we're talking about the phenotype of those, all individuals would show the dominant phenotype. So again, with tongue rolling, one parent passed down the roller trait, one parent passed down the recessive non-roller trait, but that kid is still going to be able to roll their tongue, okay? So that phenotype will still be that they are a tongue roller, okay? Let's do some examples just like we did on the last time, okay? So what we see is the allele. It looks like our genotype on this is little q, so our allele must be Q, okay? Again, we don't actually see a Q on our genes or on our DNA. It's just something that scientists use to represent those genotypes and those genes. Okay, so it doesn't really matter which letters you guys use, as long as you use the correct capitalization of those letters. Okay, so the allele we're using in this one is Q for no reason in particular. The genotype that we see of this individual is little q, okay? So again, if we're talking about non-roller versus roller, okay, this individual would be a non-roller. So let's just go over our vocab for this. Really, that's the hardest part about this unit is wading through all the vocab. Okay, so little q, is this homozygous dominant, homozygous recessive, or heterozygous? So let's go back and review this. Remember that if it starts with this HOMO or homo, okay, that means they're the same, okay? Hetero means a mix, so that means we'd see one dominant and one recessive, or one big letter and one little letter. So I look at that and I see two little letters, so I know it's not a mix, it's not heterozygous. So that means it's either homozygous dominant or homozygous recessive. Remember that if it's dominant, we're going to use capital letters. So if this were homozygous dominant, we use capital Q, okay? We use little q. So that one's mean this is homozygous recessive. I'm just going to put homo recess or REC so you guys know. Okay, or you guys can do an HR is fine too, okay? If you guys are doing this in paper, I'd prefer you guys write it out, but obviously you guys are at home, so you're doing it on the computer. Okay, are we going to see a dominant or recessive phenotype for that? So it really doesn't matter what trait we're looking at, okay? If we have a dominant trait versus a recessive trait, these two little q's are both recessive, so we're going to see a recessive phenotype show up. So if we're talking about tongue roller, this kid would be a non-roller, okay? Big R, little r, obviously we're using R for this allele. Okay, it looks like we have one of each. And remember that hetero means mixed. So we're going to put right here, hetero. So it's heterozygous. Okay, I guess I can go ahead and write all that out. Okay, and would this show up with the dominant or recessive phenotype? So because it has a capital R in it, or the dominant trait, we're going to see the dominant phenotype show up as well. So anytime we pass down that big letter, okay, whether it's a big R, a big Q, whatever the case is, we're going to see the dominant phenotype show up. That physical appearance for that trait is going to be dominant. Okay, we're using B's for this one. Okay, so with this one, we can see that they're both the same, so it's one of our homozygous, and because they're both capital letters, we're going to say homozygous dominant. Okay. All right, and so what are we going to see with this one? Obviously, both are dominant traits that are passed down, so we're definitely going to see dominant here. Okay, and what we see in real life is that we're talking about one gene with this, but a lot of times things like eye color are influenced by more than one gene. So like I said, we think of it pretty simple in 7th grade science, but as you guys get into maybe college, it gets a lot more complicated. Okay, P's, we're using P's for this one, and we know that our genotype is heterozygous, meaning it's a mix. So remember, when it's a mix, we have one dominant and one recessive. So our goal for this one is to fill in the genotype. So because it's a mix, we would use one dominant. Always write your guys' dominant first. So your capital letter should always come first, and then your recessive second. So this one would be big P, little p. And that's how you guys would say it. What's the genotype? Big P, little p. Okay? Because it has the dominant trait, it's going to also have the dominant phenotype. Okay? All right, this one, we have homozygous dominant. So homo means the same. Dominant means they're both going to be the dominant trait. We're using Y. So in this case, it would be big Y, big Y. If you guys are ever given the opportunity to choose your own letter, I would choose something where you can tell the difference between the uppercase and the lowercase. S, not a great thing to use. O's, not a great thing to use, okay? Because they look the same whether they're uppercase or lowercase. Y's, depending on how you write your Y's, can be good, can be bad, okay? With that one, we have two dominant traits, so of course we're going to see the dominant phenotype here, okay? I'm going to do one, actually, I'm going to let you guys go ahead, take a second, pause this video, see if you guys can fill out the last 4 of this table. I'm going to do the same, then we'll come back and take a look at it. All right, let's see how you guys did. Okay, I kind of snuck a little trick one in there, so let's see if you guys picked it up. Okay, so first one we did was kind of a repeat. It's heterozygous. Remember that hetero means a mix. So you guys would get one dominant and one recessive, so your genotype would be big E, little e. Okay, and if we look at the phenotype, that individual is going to show that dominant trait. Okay, with the homozygous recessive, remember that homo means the same. Recessive means that we're looking at both the recessive traits, so we would use 2 little l. So little l is the genotype. And because all we passed down was the recessive genotype or the recessive allele, we're going to see the recessive phenotype as well. Okay, big M, or, so this next one's tricky. So what we know is we have a dominant phenotype, but there's 2 genotypes that can both give us that dominant phenotype. So this was the trick question for you guys. So you guys are using M's. And with that being said, big M would give us that dominant phenotype. If you guys were to use big M, that would be homozygous dominant. Okay? But heterozygous is big M, little m, and we're still passing down that dominant trait. So we're going to see that dominant phenotype in the offspring as well. So it could either be big M, or big M, little m. Both of those would give you guys the dominant phenotype. So there's actually 2 options, and that's what's kind of tricky about genotypes is some of them you can look at an individual, see their phenotype, and predict what their genotype is. But really, for the most part, we don't know unless we do some tests where we, do some crossbreeding and check out what their offspring look like, which kind of tricky to do with human beings because it takes 9 months to have a kid, and generally you only have one. Okay, but if we use some like fruit flies where they have hundreds of babies at a time every couple of days, then it's easy to examine what their traits look like and what their offspring are. Okay, finally, our last one here, we know we have a recessive phenotype. That one's a little bit different. It's easier to predict the genotype. So anytime we see that recessive phenotype show up, we know it's either, it's only little f for the genotype, so homozygous recessive. Okay, all right, let's go ahead and move on to finish up this assignment. So you guys did the notes. But the thing I'm grading for you guys today is this little worksheet. So right here, you guys have a link, right click it, open it up, and it's going to take you guys into this genotypes and phenotypes worksheet. Okay, so here we've got a little table to show us. The first one we're going to look at is genotypes. Write the genotypes for these people. They should be 2 letters. Use the key above. I did the first for you guys, okay? Because it's kind of tricky for me to grade this for you guys because capitalization matters. Okay, I had to do this as a multiple choice for this first section. So it should be a little bit easier than what it typically would be on a quiz. So keep that in mind, okay? So different traits we're looking at is whether their earlobes, what their earlobe shape is, hair type, dimples, thumb, and eyelashes. And then you guys can see the different variations. So here are your dominant variations. We can see free earlobes, curly hair, dimples, hitchhiker's thumb, and long eyelashes, okay? You can see the alleles that we're using for those. So capital alleles to show our dominant, lowercase letters to show our recessive, where we're looking at attached earlobes, straight thumb, no dimples, straight hair, straight thumb, and then short eyelashes. Okay, so first example for you guys, I just went through and marked all of the first answers so I could go on to the next page for you guys, so ignore that. Okay, heterozygous long eyelashes. Use your notes for this, okay? Those vocab can be kind of tricky, so make sure you guys reference back. Remember that hetero means a mix, so that means we get a dominant and we get a recessive. So if we look at these possible genotypes here, okay, there's really only one answer, and it's going to be big L, little l, where we get a mix. We get the dominant and we get the recessives, the big L and the little l. Okay, so that's your answer there. Okay, homozygous hitchhiker's thumb. Okay, there's going to be two in here where you guys see, all right, homozygous hitchhiker's thumb. Let's take a look up here. Here's thumb. Hitchhiker's thumb is our dominant. Okay, so remember with the dominant trait, this one tells us specifically that it's homozygous. Okay, so that means it must be the same allele. It's the dominant one. So big T is your answer. So that one is actually marked quick. I want to point out this one for you guys, dimples. I don't give you much vocab to tell you. We know that dimples is a dominant trait, so I really want you guys to think about that one. It's kind of like the trick one that we saw in the notes. Okay, so think about all the genotypes that would give you this phenotype of dimples. Remember, just one dominant allele needs to be passed down. So what genotypes would you see there that would do that? Okay, straight hair, hybrid free earlobes. Hybrid is another word for heterozygous, so that's a little hint for you guys. Okay, straight thumb, hybrid curly hair, hitchhiker's thumb. Once you guys are done with your genotypes, move on to your phenotypes section. You guys have the same little table to refer to, but in this one, I give you the genotype and you tell me the phenotype. Be sure to type them correctly because you guys are getting this automatically graded. So if you spell it wrong, which you shouldn't because all your answers are right here, okay, all your spellings are right here, okay, it's going to mark them incorrect. And I will check over these, but you guys do need to be more careful. When it's available for you, there's no reason you guys are spelling it wrong. Okay, big E, little e, that's heterozygous, but what we know is that that dominant trait is being passed down. So let's look up here to our big E's for our earlobe trait, and that means that that individual is going to have free earlobes. Okay, so you guys would type that answer in. I think I actually need to space that out. Okay, once you guys are done, little c, big D, there's no trick answers on this one. Okay, only on the genotypes page, because again, it's harder to predict a genotype. But when you're given the genotype, you should know what the phenotype is. Okay, turn that in when you're done. Make sure you guys hit submit. And then again, that's the thing I'm grading for you guys is this worksheet right here. So you guys can turn this in, but it really doesn't matter. The main thing again that I am looking for is how you guys did on this worksheet. Okay, I hope you guys are having a great day. I know that was kind of a lengthy video, but that was probably the most important notes that we have all year. I hope you guys are having an awesome one, and I'll talk to you soon. Bye.